Good day, my dear learners. Today's topic, we shall look at trigonometry. And under trigonometry, we are going to look at how we can obtain the values for sine 60 degree, cos 60 degree, tan 60 degree without using calculator. That will be very interesting because first let me write our topic. Trigonometry, and this is special angles. Under special angles of 60 degree, 30 degree, 45 degree. We shall try to obtain the values of these three angles without using calculator. The first we're going to do is we're going to draw a triangle, an equilateral triangle. We all know an equilateral triangle is a triangle that all sides are equal, all angles are equal, and these angles are 60 degrees. So each of these angles you see here are 60 degrees, and we shall assume the sides to be 2 centimeters each, 2 centimeters each, 2 centimeters each. And we know here is 60 degree, here is also 60 degree, here is 60 degree. After that, we are going to perpendicularly bisect this. You know that this is just an assumption, or this is what we can use in obtaining these values. Now, by the time we bisect, each of these sides will be 1 centimeter, 1 centimeter. And using Pythagoras theorem, we can say, using Pythagoras theorem, we are going to use Pythagoras theorem to obtain the height of this particular triangle. And that height is going to be our either adjacent or opposite. So first, let's call here x, for example. So if we call here x, it means that for us to use Pythagoras theorem, here becomes our hypotenuse. So we have 2 squared being equal to 1 squared plus x squared. So 2 squared gives us what? 4, which is equal to 1 plus x squared, because we all know 1 squared is 1. So picking up like terms, we have that our x squared is equal to 4 minus 1. So our x squared is equal to 3. Therefore, our x is equal to root of 3. For that reason, we have that our triangle, if we are going to redraw this triangle now, our triangle will look like this. Our triangle will look like this. Here is 60 degree. Here now, because it was bisected, is now 30 degree. Here is also 30 degree. Here is 2 centimeters, 2 centimeters, and here is 1 centimeter, 1 centimeter, and here is root 3. Good. So with this our default triangle, we are going to obtain the values of sine 60, tan 60, and cos 60. So the first one, sine 60 degree, which we all know that sine is opposite over hypotenuse. So sine 60 becomes, from our triangle here, opposite, which is root 3 over hypotenuse being what? 2. So if you take your calculator, you can press and find out if the value of sine 60 is equal to root 3 over 2. Again, cos 60 degree, cosine is adjacent over hypotenuse. If you remember the acronym SOHCAHTOA, which says that sine is equal to opposite over adjacent, opposite over hypotenuse. Cosine is adjacent over hypotenuse, and then tan is opposite over adjacent. So here our cos theta, or our cos 60 degree, is adjacent over hypotenuse, and adjacent of this is 1, and then hypotenuse is what? 2. So you can press your calculator to find out if cos 60 is actually 1 over 2. Then let's go to the next one, tan 60 degree. Tan is opposite of adjacent, so opposite of 60 degree here is root 3, adjacent is 1, so it means that tan 60 is root 3. You can also verify this value. Let's also look at sine 30. So sine 30, from our diagram, you will see clearly here that sine 30 is going to give us sine 30. Let's write it out. Sine 30 degrees. Sine is opposite of our hypotenuse, so opposite here will be 1 and hypotenuse is 2. So we have that sine 30 is 1 over 2. Then cos 30 degree as well. Cos 30, if you look at it, 30 degree, cos adjacent is root 3, and then hypotenuse is 2. So we have that cos 30 is root 3 over 2, and then tan 30 degree, tan is opposite of adjacent, which is 1 over root 3. So you can clearly see here that we have achieved the value of 60 and the value of 30 degree. Now let's look at 45 degree. For 45 degree, we are not going to look at an equilateral triangle. We're going to look at a perfect square. A perfect square here, a perfect square of all sides 1 centimeter. So here is 1 cm, here is 1 cm, here is 1 cm, here is also 1 cm. That is diagonally bisected. If you diagonally bisect something, you are going to have something like this. And when by the time you diagonally bisect, you have here as 45 degree, you equally have here as 45 degree. Can repeat that for this 45 as well. Here is also 45 degree. And our next job is to find the value of the diagonal, and still using the same Pythagoras theorem. So still using Pythagoras, what are we going to do? We have that if we call here x, it means that our x squared is equal to 1 squared plus 1 squared. So our x squared is equal to 2. Therefore, your x is equal to what? Root 2. So here, rather than writing this, we can write here as root 2. Now, we have obtained all the ingredients we need for this particular work we want to do, finding the sine, cosine, and tangent of 45 degree. So we have that the first one, sine 45 degree. Sine, you have seen, is opposite of a hypotenuse. So what is the opposite of 45 degree? From here, opposite of 45 is 1, and the hypotenuse is root 2. So we have 1 over root 2. But if you recall that in mathematics, leaving a surd or a radical at the denominator is not always appropriate. You have to do what we call rationalization. Rationalization is not a big problem per se. It's just simply looking at the value of your denominator, and once you have the value of your denominator, just multiply all through by the value of the denominator, both numerator and denominator being root 2. In this case, we have times root 2 over root 2. You can see clearly that you have not changed the value of what we have, because root 2 over root 2 is still 1. So, but it will just help us to resolve faster. So we have that root 2 divided by root 2 times root 2 gives you root 4. So you have again that this will give you root 2 over root 4 is what? 2. So the value of your sine 45 is root 2 over 2. Good. Now let's go to tan 45. Tan 45 degree. Tan is opposite of adjacent. So what is the opposite of this? Our opposite is 1 over adjacent is what? 1. So tan 45 is equal to 1. And again, cos 45 degree. Cosine is adjacent over hypotenuse. And what is our adjacent? Our adjacent from here is root 2 over 2. So you can see clearly that sine 45 has the same value as cos 45. Now in our next video, we're going to see how we can use this value of sine 45, cos 45, tan 60, cos 60, sine 60, all the trig ratios actually, in solving simple problems that concerns trigonometry. Till then, have a nice time and see you again.